Okay, so we're going to go ahead and reread the essential question, the I can statement to yourself. We're going to read them together. All right, let's see. Alyssa, can you read us the essential question, please? Perfect. And then Juliana, can you read us the I can statement, please? Perfect. So I'm going to teach you a second method to do the same thing we just took a quiz on. Remember how you were struggling doing the GIM kit? This might make it easier. Okay? Huh? Because you have to understand, because we're trying to move this connection from what's on a right triangle into what's on the unit circle. Okay? So I had to kind of teach you that. But the good news is when you retake the quiz, if you didn't do well, you'll know how to do both ways, right? Okay, so first thing what we're going to talk about is we're going to kind of revisit what on earth the unit circle is. I just lost my mouse. Here we go. What the unit circle is. And then I got to talk about some trig identities, which are like formulas, okay? And then we're going to get into a couple of examples that are not on our built unit circle. All right, so the unit circle, we talked about this the other day. It's a circle. Its radius or length is 1 unit, okay? When we're gonna the equation of a circle, which you may or may not have done in geometry. I don't know how far Rondeau and the other teachers got last year. Okay, so technically, a circle has an equation. That's the equation of the circle. It's a circle with radius length 1. Okay, this is the radius length is on the right side of that equation there. Okay, so the official definition or the official properties of a unit circle is that each value on the unit circle corresponds to a set of coordinates. So each one of these radians that comes out corresponds to an xy value, which would make sense. It's on a graph, right? Well, those xy coordinates correspond to the cosine comma the sine. It's in alphabetical order. So it's going to actually give you the sine and the cosine of the circle. We're going to prove that to ourselves in just a minute, okay? In just a couple minutes. You're going to take my word for it now, and then we're going to eventually connect it back to the triangles, okay? Now, we know we have way more trig ratios than just sine and cosine, so we have to be able to get the other ones. Well, the other ones, there's some special trig identities. We've already talked about the reciprocal identities. We know that if we've got cosecant, that's 1 over sine, right? It's the reciprocal of sine. Okay, so write these out in the left-hand column because you're going to need them. I will get them reposted. I had them on both sides of the room. I took them down when I did the first round of SBAC testing. I will put them back up, okay? Because we've got a bunch of these things that we do. And then you don't have to have them written anywhere. They're posted in the room, okay? All right, what's secant the reciprocal of? Cosine. So it's 1 over cosine. Or you just flip whatever your cosine ratio is, right? But technically, that's the reciprocal. Well, we would write the reciprocal. For tangent and cotangent, the problem is all I'm going to get on my unit circle is cosine and sine. So I have to know tangent and cotangent in terms of sine and cosine to be able to write them off my unit circle. So these two are called the quotient identities. We're not going to write the name down, but that's what they're called, the quotient identities. Tangent is the sine over the cosine. And cotangent would be the reciprocal of that. The cosine over the sine. Okay? And you just need to know that they're like any formula I've given you, like area of a rectangle. It's kind of a true formula. Okay? So that's all that the identities are like little formulas. Okay. Using our newfound knowledge, knowing that your x coordinate is the cosine and your y coordinate is the sine, right? It's in alphabetical order. I'm going to zoom that back out. Okay. Alphabetical order. C goes before S. Okay. So your x coordinate is your cosine value and your y coordinate is your sine value. And like I said, I'll prove it to you here in a few minutes. We're going to do this first example and then we will go back to the one unit circle we built. All right. So I'm going to find the exact value of the 6 Trig's functions based on the angle theta. So here is our angle theta in example 1. It's not zooming. Zoom. There we go. A little bit blurry. So I know that this coordinate here is my cosine, and this coordinate here is my sine. So I'm going to write what I know. Cosine of theta equals -4/5. I'm going to leave a little bit of a gap. I know that the sine of theta equals 3/5. And I know that I get to read it right off of the coordinates on the circle. Okay. All right. What's the reciprocal of cosine? Secant. There's lots of ways to figure that out, right? We're going to have these little identities posted up in the room, right, eventually. Or could you go back and look at your SOHCAHTOA signs? It's there too. Like the hint is there too. Even though we're going to do this in a different way, the hint is there for what it means. Okay. All right. So all I'm going to do is flip this, right? I get that one for free. Woohoo. All right. What's the reciprocal of sine? Say it louder. Heard somebody say it. It's not cosine. Cosecant. Okay. So all I have to do for cosecant is flip this. Nothing new, right? On the flipping part, we've been doing that for a couple weeks now. Okay. Since we started trig, we started flipping that the first day. Okay. All right. What's missing if I have to do all 6? Tangent, cotangent. Okay. So let's use our new method. Instead of having to do Pythagorean theorem, okay, instead of having to do one of those things and drawing a triangle, we're going to go ahead and use our coordinates. So for tangent, I'm going to use my new thing. Tangent says that it's supposed to be the sine divided by the cosine. So I'm going to take my sine coordinate, which is 3/5, and I'm going to take my cosine coordinate, which is -4/5. And I'm going to reduce that. All right, I'm going to show you the long algebra way, and then we're going to see if we can come up with a shortcut, because I know you all love shortcuts, right? All right, the long algebra way would say, in order to get rid of the complex fraction, we have to flip and multiply by the reciprocal.
Can you show the side thing again?
How I got 3/5 over 4/5?
No, like the thing that we put in the side.
You want me to show this?
Yeah.
Okay. All right, are we okay where we're at? So I've got sine was 3/5, cosine was -4/5, and then I got to get rid of the complex fraction by multiplying by the reciprocal of the denominator. That's not something new. It's something we learned somewhere along the way in our math careers. Okay. All right. When I have these little fractions here, what happens? If I'm doing the arithmetic, what happens? Yeah, the 5s cancel, don't they? So 5s cancel, I would be left with -3/4. Which, once I have that, cotangent's easy, isn't it? Can't I just flip the reciprocal for cotangent? So it'd be -4/3. All right, I said I promised a shortcut, didn't I? All right. Anytime we're going to do this flipping reciprocal, what did you notice about these denominators? They're the same. So when I have the denominator the same in a complex fraction, guess what happens? They just cancel out. So do I really need to do this flip reciprocal? If I recognize it, I could just cancel the denominators, and look, the simplified fraction is right there. It's the -3/4. Okay, so that's okay for you to do. All right, I allow that nice little shortcut. All right, here's what I want you to do. I want you to try to do example 2. Remember, your cosine is first, your sine is second. You literally write those 2 coordinates down out of the unit circle, and then do all your flipping and your sine over cosine for tangent. So I'm going to give you a minute to try it on your own. Okay, and I know it's a little bit weird because it's new. Okay, but try it. Okay. What was the cosine? -5/13. So what does that make secant, everybody? Good. What about sine? Okay, I want to hear everybody, not just Robert. What's the sine? What everybody put? Okay. Check it with your neighbors. Compare what you got with your table partners. Okay, let's try that again. What did we get for sine? Okay, I'm going to say it again. I'm going to wait for the whole class. Remember, all we're doing is reading this out of the coordinate. So what did we get for sine? It's a little bit better. Still a little bit sad, though. All right. What about cosecant? When I flip it, what do we get, everybody? Better. Okay. Tangent is got to be what over what? What did we learn today? Sine over cosine. Okay, so we're going to write our sine. What was our sine? -12/13. What was our cosine? -5/13. What happens with the 13s? Okay, shortcut cancel. And then what happens with the double negative? Positive. Did you notice that we're not having to worry about all positive signing? We're not having to worry about the quadrant positive and negative thing right now, are we? With the coordinates. Okay. It's taking care of it for us. All right. What was cotangent if tangent's 12/5? 5/2. Aren't those all familiar numbers? The 3, 4, 5, 5, 12, 13. They all just came back. Okay. All right. So now let's put this on the unit circle that we built. Okay. So I'm going to go back over to kind of our other note page here. I'm going to explain it. All you're going to do is watch for a few minutes. Okay. I want you to pull your unit circle that we just rebuilt in front of you. Okay. And I'm going to mess with this one here a little bit. Okay. So let's just look at pi/6. So I want you to look at pi/6. Which reference triangle should I be working with? The blue one. Okay. All right. So I'm working with this blue reference triangle, and I'm going to try to find the sine of that blue reference triangle. Okay. Sine of, and it doesn't matter if I said pi/6, right? Which is 30 degrees. And I'm writing a 3 instead of a 6. Okay. So sine is what in SOHCAHTOA world? Good. What's on my opposite? 1. What's on my hypotenuse? 2. That is the y coordinate here. So when I write this out and I write it as a coordinate, that's the y coordinate that I just created from the triangle. Okay. We'll write this all in our unit circle in just a minute because I was doing the vertical part of the triangle there. Okay. Because the sine was the height, or the opposite was the height. Okay. All right, let's now do the cosine of that triangle. What's the ratio for cosine in SOHCAHTOA world? Adjacent over hypotenuse. I'm going to do the cosine of pi/6. All right, so what's on my adjacent? Notice I went horizontal, right? That's in the horizontal direction is my square root of 3. What's on my hypotenuse? 2. That's now my x coordinate. Okay. So what we're going to do is, that's where it comes from. It comes from the triangles, okay? All the coordinates that I'm going to give you. The other thing that we can add in now is we can also add in the quadrant angles. Remember how I said we're skipping those for now? Because I was going to wait till we did coordinates, okay? So we're going to put all of our quadrant angles on there as well. All right, so I'm going to get out my fancy unit circle that I have animated and everything, okay? And we're going to write down all of our coordinates, okay? Let me get it going. It takes a minute. PowerPoint's a little bit tricky. I call this the unit circle as easy as 1, 2, 3. You're going to see why. Okay. Gotta swap it and then duplicate it. Okay, so there's our unit circle. We've got the all students take calculus thing. Okay. Got all of our, I'm just going to click through all the angles. So we've got our over 4 angles. And we've got all of our over 6. All of them are, I made them all blue in this particular one. So, all right. So now I'm going to start putting on, I'm going to start putting my coordinates on it. I'm going to start with my quadrant angles. Okay. So my first angle here, so you're using this to fill in your green, blue, or pink on the outer ring of your circle. So go to the very outer ring where we have the new coordinates. Everybody's filling it in, okay? You're now going to get to use this new one on the next time we do a quiz, okay? So that first quadrant angle at 0 and 2 pi is going to be 1, 0, right? That makes sense. We're out 1 to the left and we go up 0, okay? Our next quadrant angle up here at the top is 0, 1. Okay, so we're out 0, up 1 on our xy axis. All right. On pi, we are out -1, up 0. Okay. And then down at 3 pi over 2, we are out 0, down 1. Okay. So if I asked you to find the sine of 0 or 2 pi, you would tell me that it's 0 because that's the y coordinate. If I asked you to find the cosine of 0 or 2 pi, you would tell me that it is 1. Okay. All right, so the next thing we do is we write all of our parentheses, which you have all nicely written for you. And I know this is oriented just a little differently than yours, but hopefully you can figure it out. Okay, the next thing I'm going to do is count. And again, I'm showing a shortcut because guess what you don't get to use next year in calculus? Your fancy unit circle, okay? You get to use it this year. Next year, I take it away, okay? So you have to be able to write this out and write it out fast, okay? So as we're building it, I'm kind of showing you that method. This is pretty much the first lesson I do next year. Okay, we review this. All right, so we're going to see how this is 0. We're going to count to 3. We can all do that. All right, so from 0, I'm going to count up. 1, 2, 3. Write that down. Leave yourself a little bit of space because notice it's kind of a top. We're going to write a fraction in there eventually. Okay. All right, up here at the top, we've got the x value is 0, so I'm going to count down on these. 1, 2, 3. Big hint. One of them is always, the two numbers are always going to add to 4. Okay? They always add to 4 in the numerator. All right, then I'm going to divide. Let's see, I'm going to divide everything by 2. So divide everything by 2. Because we already proved this square root of 3 over 2 and 1/2, right? We talked about that, so I'm just giving you the other ones. We could prove them, but I don't think we want to spend that time. Then what we're going to do is technically we're going to put a square root over the top of everything. But what's the square root of 1? So it doesn't make sense to put the square root over. So technically there's a square root over everything, and then the 1, we take the square root and it's 1. In quadrant 1, we know that everything is positive, so that's what the A is, remember, is all. So I don't need to put any signs on it. All right, we're going to count down now. Okay, so I'm going to count down from 0. I'm going to go down 1, 2, 3. My 3-year-old could do this counting, I think, today. Maybe not divide by 2, but he could do the counting. All right. I'm going to count from this 0. I'm going to count up. 1, 2, 3. Okay, same pattern. What do we divide everything by? 2. Good. What do I have? What's the next step? What do I have to do on the top? Square root was the next step. So square root what you need to square root. I'm going to give you a minute to catch up because I know it takes a minute to write all that on there. Again, make sure you're filling this out because you're going to want this for your next quiz, which won't be on Monday, okay? Maybe Tuesday, but not Monday. We might go Wednesday. All right. I now need to add negatives, okay? Because in this quadrant, something is negative. Remember, in this quadrant, only sine and cosecant are positive, which means my cosine coordinate, which is the x coordinate, is negative. So make all your x coordinates negative. So I just dropped a negative sign on all my x's. Again, make sure you're writing it and you double check that you're accurate on this because you get to use it on a quiz and on GimKit, right? And we'll do that to practice if we've got time. I'm not sure I'll have time today, but we'll have time Monday, okay, to practice. All right. All right, we're going to count down from this 0 right here that's in the y coordinate. So go 1, 2, 3. What do we divide everything by? 2. Perfect. Maybe. Where's my 2's? Oh, I forgot to do the up part. Sorry. I got to count up from that 0. 1, 2, 3. I forgot the counting up part. Then divide by 2. After we divide by 2, what are we supposed to do? Square root everything. Good. Okay. Look out in your orange ring. Because that orange ring is still useful. You still need to understand what's positive and what's negative in each quadrant. Because sometimes the problem isn't good for coordinates, and we have to know some other stuff. Okay. What's allowed to be positive in quadrant 3? Tangent and cotangent. So guess what? Sine and cosine, which are those, are both negative. So you're going to drop negatives onto everything in those quadrants. Okay. Finally, quadrant 4. From this x coordinate, I'm going to, because it's 0, I'm going to count up 1. Maybe 1, 2, 3. Okay, we're going to count down from that 0. 1, 2, 3. Do you like how that first one, it flew up instead of down? It's been like that for like 10 years. Never fixed it. Probably longer than that. Okay. What do I divide everything by? 2. What am I going to put over the top next? It's great. Do you notice how we're getting what we started the whole day with rationalizing, and those were some of the answers we got when we rationalized. Some of them, we didn't get the square root of 3 over 2, but we got the other ones, right? All right. So in quadrant 4, what's allowed to be positive? Cosine and secant. So cosine's the x, which means I have to make my y negative because y is sine. So make that negative. Okay. All right. Take one more minute. Look, double check to make sure you wrote everything correctly. Okay. All right. We're going to use this now. Okay. I'm going to end that one. Go back here. Okay. I'm going to pull my little unit circle in here. Okay. First thing that it's asking me for in these first 3 examples is just find the point on the unit circle that corresponds with the real number, because all we did was just create coordinates, right? So 2 pi over 3, what quadrant is 2 pi over 3 in? Second quadrant. All that it's asking me to do is write that coordinate down. Okay, so I'm going to write that coordinate, which is -1/2 square root of 3 over 2. All right. Is negative pi over 4 on our unit circle? No. What are we going to have to do to find negative pi over 4? What do we have to do? Nobody knows? It's really not good, guys. Should we subtract? Okay, so I heard subtract 2 pi. Should I subtract 2 pi? Okay, we're going to add 2 pi. What does 2 pi look like in over 4 world? 8 pi over 4. Good. So what is negative pi over 4 and 8 pi over 4? Good. What quadrant is 7 pi over 4 in? Okay, I'm seeing her in 4th quadrant. So all I would write down for that coordinate is square root of 2 over 2 negative square root of 2 over 2. Okay. The other thing I could have done on that, remember when we counted the wedges? Couldn't I have counted back one? So that's another way to deal with it if you don't want to add the 2 pi. And you have your unit circle, so you could count that out. Okay? All right, everybody find the coordinate for 5, for the 5 pi over 6. So find that right now on your own. Okay, check it with your table partner. Erase. Why is it not erasing? All right, what quadrant is 5 pi over 6 in? Second quadrant. So I should have written down negative square root of 3 over 2, 1/2. Everybody good? Okay, I don't know why my thing's not erasing. Read the instructions for example 6 while I'm trying to figure out the erasing thing. It's just acting stupid. I might have to go out and come back in. Okay. All right, let's see if it lets me erase now. Good. All right. So what it's asking me to do is I have to find sine, cosine, and tangent of pi over 6. All right, so I'm going to use all the stuff we've learned so far to find that today. So I'm going to write out sine of pi over 6, cosine of pi over 6, and tangent of pi over 6. I could find all of them, but this is where it's baby stepping me into this right now. When you do the assignment, okay, because I gave you a delta math, it's not going to ask you for all 3. It's just going to ask you for 1, and then it'll move you on to the next one, and it'll move you on to the next one, and so on, okay? All right. Is sine, first of all, which quadrant is pi over 6 in? First quadrant. Okay, is sine the x coordinate or the y coordinate? It says right here, what is it? The y. I should hear everybody. These are the questions you have to ask yourself, okay, over and over and over, okay? All right, so it's the y coordinate. So my sine is going to be what? 1 over 2 or 1/2. Done. Didn't have to look at any triangles. I could have, right? I could have done it, but I just get to write the 1/2. Okay? All right. Cosine. Is cosine the x coordinate or the y coordinate, everybody? Okay, I want to hear everybody. Cosine the x coordinate or the y coordinate?
The y coordinate. X coordinate.
All right, there we go. I think we got. Okay, let's try it one more time. Okay? It's okay. Junior's brain just grew. When you make mistakes, your brain grows. All right? All right, his brain's growing bigger than everybody's today. All right, cosine of pi over 6, is it the x coordinate or the y coordinate? X coordinate. Okay, so x coordinate, so we're going to write square root of 3 over 2. All right, the tangent. We can't just read it off, right? What did we learn today? What is tangent in terms of sine and cosine? Sine over cosine. So I usually write this because I'm lazy and I don't want to write out the whole world. I'll usually write out sine over cosine like that, okay? Just to get to process it in my brain. All right, we already wrote it here. What was our sine? 1 over 2. What was our cosine? Good. Is there another nice little shortcut we learned today that we could take right here? Oh, the 2's can cross out. So we got 1 over square root of 3. Am I allowed to leave it like that? No. What are we going to see what do I have to do to it? Rationalize it. I bet by next week we have that memorized because we're going to use it a lot. So it's square root of 3 over what? 3. I get super tired, I know, because I write it like 500 more times than you all do. But of rationalizing, and it's the point where 1 over square root of 3 is the same as square root of 3 over 3. Okay? All right, we're going to try a few more here together. Okay? And, oh yeah, we got time. All right, On example 7, it says now we've got to do all 6. Wasn't that nice of them? All right, so I've got to find all 6 of these things this time. I do like when I'm writing this out to line up my reciprocals. So let's do sine of 5 pi over 4, cosecant of 5 pi over 4. So I'm just going to write out that part of it. And then I don't know why I like starting with sine. That's just kind of the way we've always done it. So I'll give you a minute to write all of these out, and then we'll try to plop them in there. Cosine, it's tangent, cotangent. Okay. What quadrant is 5 pi over 4 in? Okay. So that's the coordinate you should be using. I want you to see how far you can get with it without my help. You can do it. Write down the sine, write down the cosine. Remember, sine is the y, cosine is the x. You may need to rationalize somewhere. Give you about 40 more seconds on your own. Okay, I want you to check them with your table. Check them with your table. Have a discussion about it. Okay. So, what did we, is sine the x or the y, everybody? Okay, I asked everybody, sine the x or the y? Y, okay. So what was the y coordinate? Good. All right, is cosine the x or the y, everybody? I didn't hear everybody. I heard Robert really loud. Okay. All right, is cosine the x or the y? I'm going to say it again. Is cosine the x or the y? All right, it's the x. What's my x coordinate? Hard to mess that one up because they were the same, right? All right. What do we have? What's tangent in terms of sine and cosine? Sine over cosine. So I'm going to write negative square root of 2 over 2 divided by negative square root of 2 over 2. What's that equal? Isn't it the number on top of itself? What is that always reduced to? It's 1, right? If I had just 2 over 2, you would tell me it is. It's just a funny looking 1, right? It's okay. It's a funny looking 1. All right, let's do all the reciprocals. Okay. So I know that cosecant is the reciprocal of sine. So what do I get when I flip? It's negative what? 2 over square root of 2. Am I allowed to leave the square root of 2 in the denominator? No, so I need to rationalize. And this isn't one that we practiced earlier. So negative 2 square root of 2 over 2. Ooh, what's going to happen with these 2's on the outside? They cancel, so it'd just be negative square root of 2. Which, if we were in the triangle method, that one actually would have probably been easier on triangles. Okay? I know, I still prefer coordinates, so you're going to have to rationalize some way, somehow, somewhere. Okay? All right. Do I need to do all that work again? I already did it, didn't I? So I know that this, when I rationalize it, is just going to be negative square root of 2. What about when I do the reciprocal of 1? What do I get? 1. Okay. Look at what happened there, you guys. The signs were set up for us, weren't they? In this quadrant here, only tangent and cotangent are positive. We got positives. Everything else, look at what we got. Negatives, without having to worry about my orange ring and think about it. Okay, that's the benefit of coordinates. All right. Okay, let's see what we're doing time. We get out at, I don't know. What time is it at today? 59-ish. Okay, we got time. All right. We're going to let's try at least one of these, and then I want to talk about quadrant angles. We might do both of them. And then we will, we're not going to do this last, we're going to save this for Monday. I don't want to push more today. Okay, so we're going to save that part for Monday. All right, is 11 pi over 3 on our unit circle? No. Have you noticed that we haven't done any degrees today? Okay. If it gave it to you in degrees, it's going to be the same thing. I did a delta math. I gave you part of it in degrees and part in radians. It's going to work the same way. Okay. But we're making that transition because as we grow in calculus, we only use radians. So we're going to transition into radians here. All right. It gives us a hint. We have to add and subtract 2 pi. Am I going to add or subtract 2 pi? Subtract. What's it going to look like in over 3 world? 6 pi over 3. Okay, so this is the same as finding the sine of what? What's 11 minus 6? 5 pi over 3. Good. All right. Sine of 5 pi over 3. So what quadrant is 5 pi over 3 on in our unit circle? Quadrant 4. Okay. And is sine the x coordinate or the y coordinate? The y. So I'm going to write down negative square root of 3 over 2. Did it ask me it only asked me to evaluate that one, right? It didn't ask me to do more than one. So guess what? We're done. Okay. Most of the time, it's just going to ask you to do one thing. It's not going to ask you for all 6. Okay. All right. So let's do this one. Actually, I want you to try that one. Are you going to have to add or subtract on that one? Add. Okay. So figure out, add 2 pi. Make sure it's the over 4 2 pi, right? And then figure out what the cosine is of it. Okay. I want you to check it with your table. Okay. What did we add? A pi over 4. So we're really looking at the cosine of what? 3 pi over 4. All right. Cosine of 3 pi over 4 is cosine the x coordinate of the y coordinate, everybody. Okay. It's cosine the x coordinate of the y coordinate, everybody. X. Okay. So my x coordinate negative square root of 2 over 2. Everybody good? Okay. We're going to add a couple that aren't on there because I want to make sure you're good on the quadrant angles because that's going to come up on the homework. So we're going to add a few more. Okay. We'll just call it example 9A and example 9B. Okay. We're going to do 4 of them. Example 9C, example 9D. Okay. So let's do the sine of, let's say, pi. here we're going to do the secant of 3 pi over 2. This one we're going to do the tangent of pi over 2. And this one we will do the cotangent of pi. Hopefully those don't come out. Actually, we're going to do the cotangent of pi over 2. All right. So these you're going to notice are going to land on our quadrants. Okay. And there's some weird things that start happening when we land on the quadrant angles. Okay. So sine, x coordinate or y coordinate? Y, good. Y, much quicker that time. All right. So what is the y coordinate at pi? 0. So my answer to that one is 0. There was one that I accidentally left in that gim kit, right? That was on the quadrant. So yeah, so that's what's happening is we're going to use the coordinates for the quadrants. It's hard to do the triangles on quadrants, right? Because I don't have a 180-degree triangle, all right, or a 9. So I can't do that. All right, 3 pi over 2. 3 pi over 2 is down at the bottom, right? Okay. What is secant the reciprocal of? Cosine. So I need 1 over cosine, right? What's my cosine in this coordinate right here? It's 0. So I need to flip the 0, right? It's right now 0 over 1, so I need to do 1 over 0. Isn't that a problem? What are we allowed to divide by 0? If we divide by 0 and leave it on our paper too long, it will explode. So we can't have that happen, right? We don't want the fire alarm to go off again. All right, so whenever you see that, you write undefined. Okay, so sometimes our answer is going to be undefined. Sometimes it's going to be 0. All right. All right, let's look at tangent of pi over 2. That one's up at the top, right? Okay, so tangent is what over what have we learned today? Sine over cosine. So I have to do 1 over 0, right? So this is going to be 1 over 0. Am I allowed to have that? No. What do we have to write down? Undefined. I'm hoping I set up the other one the right way. I think I did. Okay. They won't all come out that way. I picked on ones I knew that would be tricky. So I'm going to be pi over 2 again up at the top, right? If I didn't have the cotangent value or the tangent value, remember cotangent is cosine over sine. So I'm going to still use this. I'm going to do the cosine on top and the sine on the bottom. So cosine is 0, sine is 1. Is that okay? That is okay. Because I'm allowed to do 0 divided by 1. It's equal to 0. I'm just not allowed to have 0 on the bottom. Okay? All right. That gets us enough for you to be able to work on the assignment. Okay? Do we want to turn on Fishtopia for like 6 to 8 minutes? Yeah. Yes? Okay, so you can use your coordinates this time. Okay? If you want to draw on the desks, you can draw on the desks. I will get Fishtopia going. Okay? We'll put it on. I also put like a gim kit out there. It's not Fishtopia, it's something else, but it's out there for you to play as an assignment. Okay? So you can get more experience points or whatever. They said that if you try your experience points too fast, then they won't give you if you're doing the questions too fast, it won't give you the experience points. All right, we'll put this on for like 7 minutes. Okay, use your coordinates. Okay. Where is it? Oh, I lost it. Come on back. All right. Oh, it's loading you in. This might take a while. Hopefully not too long. All right. There's the code. Get in there. As soon as I have one person go in, I'll hit the play button. You might not get that many fish, but at least we practiced, right? All right, here we go. I'm going to start because there's 2 people in. I'll put the code up big. All right, there's the code again. Play for a few minutes. Do like 3 or 4 of them and then go fish, right? Because we don't have a lot of time. I don't know where the fancy music is. Oh, there it is. I hear it now.
From Tuesday until next Tuesday for Christmas field.
Mm-hmm.
Can I do the test or work while I'm there?
You can do the work while you're there. So just watch the weekly work, and if I forget to put up the video, would you email me or text me and just say put it up? Yeah, okay. And then you can do all the quizzes when you get back. Okay.